Hi y'all, this is Miss Bailey again for the last bit of Unit 1 notes. You are almost done with your first unit of physics. That's exciting. So we are going to start off today by defining a couple of terms that you've probably heard before. Average speed versus instantaneous speed. And average speed is what you think of. It's that math average, it's a weird way of taking not a sum, but just gathering information about the whole speed of the trip, just combining it all and about how fast did you go if you could kind of even it out for the whole trip. So let's say you're driving to Austin and you average a speed of about 70 miles per hour and you think that's good. You're like, oh great, I was within the speed limit. But in order for you to get a perfect average of about 70, that means at some point you must have been going over 70 miles an hour to achieve that average. So just something to think about. It takes into account the whole trip, all your starts and stops and speedings and slowdowns and all of that thing. So we're taking account of the whole motion and not just beginning or end. Instantaneous speed looks like a scary physics word, but it has that word instant at the front of it. So just think of it as speed at a given instant or at a particular moment in time. So let's say on that same trip to Austin, you hit some traffic on the way to Waco. I always hit traffic on the way to, in Waco when I'm on the way to Austin. And so let's say while you're driving through Waco, your instantaneous speed is about 30 miles per hour because you're in the middle of all of that construction. Or maybe you're really unfortunate and you hit dead stop traffic, and so your instantaneous is actually 0 at a couple points in time. So instantaneous is just speed at a certain moment, a point in time over a whole trip, versus the average will take into account all of those 30 mile per hour stops and 0 mile per hour and all of those things. But again, in physics, we use meters per second. We're just in America using the empirical system, so you're used to hearing that stuff. I was trying to relate it. But anyway, good for us. We can use these terms to also help us interpret graphs and figure out things about the motion of an object. So first things first, we have a graph. We should identify what type of graph it is. And I know that seems like common sense, but eventually we will have different types of graphs we're looking at, and it'll be less confusing to you if you look at what the graph is telling you. And you guys are probably used to looking at graphs all day. You just don't really realize what you're doing. Like for instance, I have the Weather Channel app on my phone and it shows me the time or the hour of the day across the bottom, and then it shows me temperature on the little y-axis, but I don't think of it as a y-axis when I look at it because it's just telling me, oh, this is what time, it'll be what temperature, and it shows me a nice little wavy line so I can kind of picture it in my head. So that's just an example. This is a position, which is what that symbol X means, and it's measured in meters, versus time graph. So all of these numbers along this x-axis are telling me time, what time, and everything along this y-axis is telling me position, where the object is. Great. So this first example question asks, I know I'm blocking it a little bit, but I'll read it to you. How far did the object travel during the first 4 seconds of travel? So 4 is right there, and if I follow the time all the way up here, this is where the line is, which is where the object is. So how far did the person travel during the first 4 seconds? Well, they started off at -6. So if you want, break it into chunks. They moved from -6 to 0, which means they moved 6 meters to get from here to here. And then they moved from that 0 location to get to the 6th location. So that is another 6 meters. So 6 plus 6 would give me 12. So that's the answer for the first 4 seconds. How far did you travel during the whole trip? So we already measured the first chunk. That was 12 meters from here to here. What about for this next segment? How far did they travel? Well, it looks like they stayed at this 6 meter mark for this entire 2 seconds. So that means they didn't move. They stayed at the same location. So they moved 0 meters. And then they moved from 6 back down to 0. So they moved 6 meters to get from 6 to 0. And then they moved another 6 meters to get from 0 to -6. So really, they traveled 12 meters again during the second, I'm going to say second half. I know it's not exactly half, but they traveled 12 meters during the first segment, none during the second, and then 12 during the last segment. So in total, they traveled 24 meters. Great. If you're ever having trouble with graphing, I highly recommend drawing all over it the way I just did. Segment it, and it really, really helps. So what is the total displacement of the object at 2 seconds? So how far did the object travel at 2 seconds? And this is a little different from distance, because displacement, if you recall, keeps track of direction. So for the first 2 seconds, 2 would fall probably halfway between 0 and 4. So where did they end up after those 2 seconds? Well, we started here at -6 and we ended at 0. So you would say they traveled 6. We already kind of figured that out in the first problem. But where did they end up compared to where they started? That's what displacement is. How much have they been displaced? And that's the difference between displacement and distance, is there's a direction involved. So they ended up 6 meters away from where they started, but they ended up 6 meters in the positive direction compared to where they started. So that's where we got this answer from, +6 meters. Next segment of the question asks, what is the displacement at 8 seconds? So up here. So at 8 seconds, they traveled another 6 meters, we figured out from the first question, but also in that positive direction. So 6 meters and another positive 6 meters. But then they traveled no meters for 2 more seconds. So altogether, that'll end up being +12 meters. They ended up from here to here, +12 meters from where they started. And for those of you who like math, displacement is technically final position minus initial position. Final position is +6. Initial position was -6. Oh my gosh, look at that. Those negatives cancel each other, and I end up with +12 meters. Great. Over the whole trip, what is the overall displacement? Well, from beginning to end, what is the overall displacement? From -6 to -6, if I ended up back where I started, what is my overall displacement? 0. So I know it seems like he didn't. Some of those of you who are just bogged down by the shape, well, he ended up over here. The difference is the time. He ended up over here at 20 seconds, but he's still, this is telling me where he is, right? This whole segment over here. And they're back at the same point on that y-axis, which means they're back where they started. Great. Next part. What is the average speed of the object over the whole trip? So speed, there's a couple ways you can do this, but speed is equal to distance over time, right? And they're asking for the average speed over the whole trip. Lucky for us, we already calculated the distance for the whole trip in the first part of the problem, so we could just do some math. But maybe you have this problem and it took 20 seconds. I have to look at the whole thing, and that's where I get 1.2 seconds. But maybe you didn't do this first part. Maybe this first part wasn't part of a test question, and so we didn't have that available to us. How would I calculate average speed? You could kind of look at the graph and figure it out. You would have to do the segment thing, like I talked about. So for the first segment, travel 12 meters. 0 meters plus another 12 meters would be my total distance divided by time. Treat it like a little math problem if you want. And then second part of the question asks, what is the average velocity over the whole trip? So the average velocity is displacement divided by time. So we also, lucky for us, calculated the total displacement. But since it's over the whole trip, if they didn't give us that first part, you could see total displacement is 0. He ends up back where he starts, which is why, no matter what the time is, overall velocity for the whole trip is 0, which I know kind of blows some of your heads. But maybe this next part will make you feel a little better about those numbers. The last couple of questions are asking you to find the instantaneous speed at several different locations. So the first location is at 6 seconds. At 6 seconds, I am, and this is getting a little messy, I apologize, right here where I'm not moving. So that instantaneous speed is 0. Easy enough. At 12 seconds, how fast am I moving? And that's right here. And you can see that the object is definitely moving. The object, or the line, definitely has a slope, so the object must be moving. So how do I find how fast that person is going? Well, maybe you remember from the notes, or maybe you remember from a different activity, that the slope of the line tells you how fast you're going. And I can see that they definitely went kind of fast right here, but this line is a little bit less steep, so if you wanted to compare the two, this one would not be as fast as that first segment. And it's definitely less flat than 0, so they're definitely moving. So how do I figure it out? Speed is still distance divided by time, so some of you are going to be tempted to do distance divided by time, but that's not exactly correct. It didn't take 12 seconds to just move to 2 meters. It took 12 seconds to go all the way around. So that's still taking the average. You want to just find how fast they're going during this segment where the slope is the same. You're noticing I'm saying the word slope a lot, I hope, because we're actually going to use the slope formula, which maybe you remember from math is change in rise over change in run, or change in y over change in x. But in this case, the y-axis is position, which I know that gets confusing, and the x-axis is time. So I think the math equation you use is like y2 minus y1 over x2 minus x1. That is very similar to final position minus initial position over final time times initial time. They're essentially the same formula. So you're using slope to figure out how fast you're going, but this is also the formula for how fast I'm going. So don't overthink it too much, but I basically want to take 2 points anywhere where this slope is the same. And I like to take 2 points where they're definitely crossing a specific point. This one is okay, and since they go by 2s, we can probably estimate what that is, but I just like to be sure of myself, so I probably won't use that point. But you could use it, or you could use any 2 points, even beginning and end, anywhere where the slope is the same, and you should still get the same value. It's just like in math class where everywhere the slope is the same, you can pick any 2 points. So again, I'm going to use those 2, so I'm going to do position. I'm going to pick this point first. It doesn't matter which point you pick first, just make sure you keep it consistent. So 2 minus negative 2 over the time is 12 minus 16. So I get those cancel, 4 over negative 4. I end up with negative 1 meters per second for my speed. And I know that's frustrating to get a speed that's negative, but it's just telling you a direction. And because in this particular direction it happens to be opposite of this side, that's why we ended up getting a direction. Since we are just giving a speed, you could drop that negative. I'm not going to count it wrong if you include it. You're just being extra thorough. Just please be sure if they're asking for velocity, you give a direction with that. But negative 1 meters per second would be how fast it's going at that particular moment. If you were to solve, you could practice if you want to solve for how fast you're going on this side, and it should be faster than the first side we solved for because it has a steeper slope. Ask your teacher if you have issues with graphing, and they will try their best to help you.